In this video, I'm going to show you how to find the real roots of polynomial equations using the rational zeros theorem. Here we want to solve this polynomial equation x cubed plus 3x squared minus 3x minus 5 equals 0, where x is a real number. Now, this is a difficult polynomial to factor, but thankfully we have this thing called the rational zeros theorem, which tells us about the potential rational zeros of this polynomial. So, rational zeros theorem, the possible rational zeros are factors of the constant, factors of -5, so factors of -5 divided by factors of the leading coefficient, which here is just 1, over factors of 1. So that corresponds to factors of -5, that's plus or minus 1, and plus or minus 5, over factors of 1, that's just plus or minus 1. So the end result there is just plus or minus 1 and plus or minus 5. Now these are the potential rational zeros. So not necessarily these are rational zeros, but if this polynomial has a rational zero, then it's got to take one of these forms. So why don't we try testing out these zeros? So first of all, let's try, how about x equals positive 1? Is that a 0? Well, we can test that by just plugging it in here. So just 1 to the third plus 3 times 1 squared minus 3 times 1 minus 5. That's just equal to 1 plus 3 minus 5. So 4 minus 8, negative 4. That's not equal to 0. So x equals 1 is not a 0, unfortunately. Okay, well that's okay. We've got other possibilities. So how about the next one? How about x equals -1? Is that a 0? So that's -1 to the third plus 3 times -1 squared minus 3 times -1 minus 5. -1 to the third is just -1. And then -1 squared, that's 1, so just plus 3. Then minus times a negative, so plus 3 again, and then minus 5, and that is just 2 minus 2, which is 0. Yeah, so x equals -1 is a 0 of this polynomial here. So that's telling us that we can take this polynomial and factor it into the form x plus 1, that corresponds to a 0 of x minus 1, and then times some quadratic factor. And that is going to be equal to 0. And once we find that quadratic factor, it's going to be a lot easier to solve for what makes that quadratic factor 0. So how do we find that quadratic factor? Well, we can just divide this polynomial by this factor, this linear factor, x plus 1. And we can do that using synthetic division. So we'll set up our synthetic division template and put the 0 of that factor, which is -1, on the top left, then put in our coefficients of the polynomial, 1, 3, -3, -5, and start off our synthetic division with the 0 in the first column, add down the column 1, multiply to get -1, add to get 2, multiply to get -2, add to get -5, multiply to get +5, and add to get 0. So this just corresponds to x squared plus 2x minus 5. That's going to be our quadratic factor. So let's go ahead and write that here. So x plus 1 times x squared plus 2x minus 5 is equal to 0. Okay, so using the zero product property, we know that either this factor is 0 or that factor is 0. So x plus 1 equals 0. We already solved for that. That was x equals -1. Okay, and now this factor equals 0. X squared plus 2x minus 5 equals 0. That's not easily factorable, so let's just use the quadratic equation. X equals -b, so -2, plus or minus square root of b squared, so 2 squared, minus 4 times a is just 1, times c is just -5, all over 2a, all over 2 times 1. Now, so let's just simplify that. X equals -2 plus or minus root of 4 plus 20 over 2. So x equals negative 2 plus or minus root of 24 over 2. So x equals negative 2 plus or minus. We can break up 24 into root 4, and root 6 all over 2. So x equals negative 2 plus or minus 2 root 6 over 2. So x equals negative 1 plus or minus root 6. So these are our solutions. X equals negative 1 and x equals negative 1 plus or minus root 6. We can write that in our set here. So negative 1 and negative 1 minus root 6 and negative 1 plus root 6. And there we go. There is our solution set. Here's another example. This one's a little bit tougher because now we've got a quartic polynomial, 2x to the 4th plus 3x third plus 4x squared plus x minus 2 equals 0. I want to solve that where x is a real number. And again, we're going to use the rational zeros theorem to help us. So the rational zeros theorem tells us that the potential rational zeros take the form of factors of the constant term negative 2 divided by factors of the leading coefficient, which is positive 2. So factors of negative 2, that's just plus or minus 1, plus or minus 2, and factors of 2, just again plus or minus 1, plus or minus 2. So considering all these possible combinations, we've just got it's either plus or minus 1, plus or minus a half, or plus or minus 2. So let's just go down the line testing the possibilities. So how about x equals 1? Is that a 0? So plug that in, 2 times 1 to the 4th, plus 3 times 1 to the 3rd, plus 4 times 1 squared, plus 1 minus 2, which is just 2 plus 3 plus 4 plus 1 minus 2, which is just, well, 2 plus 3 is 5, plus 4 is 9, plus 1 is 10. So 10 minus 2, which is 8, and that's not equal to 0. So nope, x equals 1 doesn't work. That's not a 0. So what's the next possibility? How about x equals a negative 1? So let's test that. So 2 times negative 1 to the 4th, plus 3 times negative 1 to the 3rd, plus 4 times negative 1 squared, plus negative 1 minus 2. That's equal to, so that's just 2, then minus 3, then plus 4, then minus 1, minus 2. So 2 minus 3, negative 1, then 4 minus 1 is 3, then minus 2. So negative 1 plus 1, hey, that is equal to 0. So yeah, x equals negative 1 is a 0, and that means that we can factor our equation into a factor x plus 1, which corresponds to that 0 of negative 1, and then times a cubic, and that's going to be equal to 0. So how do we find that cubic? Well, we can just do synthetic division again. So set up synthetic division with the 0, negative 1, and then put in our coefficients here, 2, 3, 4, 1, negative 2. Start off with the 0, add down the column, 2 times negative 1 is negative 2, add down the column is 1, then times negative 1, negative 1, add down the column, 3 times negative 1 is negative 3, add down the column, negative 2 times negative 1, positive 2, and 0. Okay, so that gives us, then the cubic is just 2x to the 3rd plus x squared plus 3x minus 2. Okay, so let's write that in here. So x plus 1 times the cubic, 2x to the 3rd plus x squared plus 3x minus 2 is equal to 0. Okay, so now we have to break down this cubic, and we just go through the potential rational zeros process again. This has the same leading coefficient and the same constant as before, so the potential rational zeros are still the same, plus or minus 1, plus or minus a half, plus or minus 2, and we've already tested 1 and negative 1. So now let's continue where we left off. Let's test x equals a half. Does that work? So let's go ahead and plug that in. That's 2 times a half to the fourth plus 3 times a half to the third plus 4 times a half squared plus a half minus 2. And let's go ahead and evaluate that. So that's 2 over 16, then plus 3/8, then plus 4/4 plus a half minus 2. Why don't we convert this all to be out of 8? So this is 1/8 plus 3/8, then plus 8/8, then plus 4/8, then minus 16/8. And 1 plus 3 is 4, plus 8 is 12, plus 4 is 16. So this all is 16/8, then minus 16/8. Yeah, that's equal to 0, so that works out. So x equals a half is a 0, and we can go ahead and factor even more. So we're going to have x plus 1, then x minus a half, corresponding to that 0 of x equals a half, then times a quadratic. And that'll be equal to 0. And to find the quadratic, we can just do synthetic division again with this x equals a half. So why don't we squeeze that in over here. So x equals a half, that means the 0 is a half. Put in a half up here, and then put in the coefficients right here in the first column. 2, 1, 3, -2. Started off with the 0. 2 plus 0 is 2, times a half is 1, plus 1 is 2, times a half is 1, 3 plus 1 is 4, times a half is 2, add down the column, 0, so just 2x squared plus 2x plus 4. Okay, so let's write that down. X plus 1 times x minus a half times 2x squared plus 2x plus 4 is equal to 0. Finally, now we've got a quadratic, and this is going to be a lot easier to solve. So zero product property, set all these factors equal to 0, x plus 1 equals 0, x minus a half equals 0, and then 2x squared plus 2x plus 4 equals 0. So x plus 1 equals 0, that just gives x equals -1, which is what we found right up here, x equals -1. X minus a half equals 0, just gives us x equals a half, which was the 0 that we already found over here. And then, ooh, this one. Why don't we simplify this a bit? Divide by 2 to get x squared plus x plus 2 equals 0. And doesn't look factorable, so let's just stick it in the quadratic equation. X equals -b, so -1 plus or minus square root of b squared, so 1 squared, minus 4 times 1 times 2, all over 2 times a, so 2 times 1, so x equals -1 plus or minus root of 1 minus 8 is -7 over 2, and ooh, that's a negative in the root sign, so that means we're going to get complex roots here, and we only are considering real numbers, so just no roots there, no real roots there. So that's it. These are our only solutions here. Our solutions are -1 and a half. And there we go. Finally, we are done. In this video, we practiced finding the roots of polynomials. In the future, though, we'll also learn how to graph polynomial functions.